Right triangles, unit circles, sine and cosine. So today we're gonna put it all together. You're gonna see it's gonna be fun. Again, we start off with a 30, 60, 90, 45, 45, 90. By now, this should already be automatic because we've been seeing it every single day, right? Because they're pretty important. All right, so here we go. We got a 30, 60, 90 triangle. I have the hypotenuse, and I want the hypotenuse. I have the long leg. So I'm gonna draw 30, 60, 90. I'm going to put the relationship n square root of 3 and 2n, where the n is the short leg, and then the long leg is the n square root of 3, and then the 2x is the hypotenuse there, or the 2n, sorry. So I'm going to go here to the side. I'm going to write n square root of 3 equals 6. To get n by itself, you just divide by square root of 3. So n equals 6 divided by square root of 3. If it's free response, and I don't tell you anything, then you would just write 6 over square root of 3. It does here with a rational denominator. It does say with a rational denominator, so that means I don't want a square root in the bottom. Of course, that's not the answer, right? That's just this guy, 6 over square root of 3. So I'm going to go ahead and double it. So if I double it, x equals 6 times 2 is? So x is 12 over square root of 3, but again, we don't want the square root of 3 in the bottom. So I'm going to multiply that sucker by square root of 3 over square root of 3. Remember, that's just times 1, guys. Anytime you multiply by 1, it's still itself. So you're going to get 12 root 3 over 3. And then how many times does 3 go into 12? So the answer is 4 root 3. Bless you. I heard someone sneeze. So there it is. Yeah, rational denominator means no square roots. Cool or not cool, guys? All right, go to the next one. It says, find the lengths of side x in simplest radical form with an irrational denominator. So again, the same thing. All right, guys, focus, focus. So this distance here is the square root of 5 because it's a 45, 45, 90 triangle. I'm going to write 45, 45, 90. I'm going to write n square root of 2. So all I got to do is take that square root of 5 and multiply it by square root of 2. So what's square root of 5 times square root of 2? Square root of 10, leave it alone. Yay or nay? Yay. All right, what do we know about sine, cosine, and tan? So let me draw a right triangle. Bless you squared. Did I hear someone sneeze? I keep hearing someone sneeze. I'm going to label these vertices A, B, C. Big A creates little a, big B creates little b, and big C creates little c. If I write, I'm going to write SOHCAHTOA. SOHCAHTOA. If I write sine of B, or angle B, sine of angle B is opposite over hypotenuse, so it's little b over little c. If I write cosine of angle B, cosine is adjacent over hypotenuse, so adjacent is little a over c. And if I write tangent, you okay? Tangent of angle B. Tangent of angle B is opposite over adjacent, so b over a. Nothing crazy. I think we're already pretty good at that, right? All right. I'm going to focus on the first quadrant of the unit circle. So I'm going to exaggerate the first quadrant. And here's my unit circle. And I'm going to go ahead and draw some random angle. So here's some random angle. And I'm going to say that's my angle theta. So this coordinate there on the unit circle is some x, some y. I do not know what x that is. I do not know what y that is. Are we still okay? So I'm going to draw my horizontal displacement in sky blue. So this sky blue here, that looks about it. That's my horizontal displacement. That's x. I'm going to draw my vertical displacement in purple or light purple. I'm going to say that's y. So I guess let me color code it. X and y. Here's my right angle of that triangle. And because this is a unit circle, my radius is 1. So that hypotenuse is 1. Have I confused anyone? Yes. Because it's one unit. It's called a unit circle because it's one unit. So that's why we just do one. Also, the radius is 1. The radius, the distance of the unit circle is 1. So this is 1. So that's why the hypotenuse is 1, because it's the radius of this unit circle. Did I explain it okay? Guys, hit me with questions because I can't tell. Any other questions so far, guys? Okay. All right, so check it out. You guys ready? I'm going to write this SOHCAHTOA stuff here. SOHCAHTOA. And here we go. I'm going to write, okay, this says sine. So I'm going to write sine of that angle. Well, according to this, sine is opposite over hypotenuse. Opposite happens to be what letter? Y divided by 1, which is just, I guess I'll write the divide by 1. Y divided by 1, which is just y. So from now on, we're going to say that sine theta is just your y coordinate. And don't worry, we're gonna talk about it. And let me keep it color coded. All right, here we go. Now I'm going to do cosine. Cosine of that angle is equal to adjacent over hypotenuse. What's adjacent? The x over 1, right? Is that what you guys said? X over 1, which is just x. So from now on, we're going to say, is everyone okay with how I got that x there? Okay, we did adjacent, which is this value, the horizontal displacement divided by 1. So from now on, we're going to say that cosine theta is simply x. Are we okay so far? All right, last but definitely not least, tangent of this theta is equal to opposite y over x. I tried to color code it as much as I could. Bam, bam, bam. How do we feel? Nothing crazy, right? Okay. All right, so let's keep going. Oh, look, the unit circle. All right, let's start. I'm going to start filling it in with the degrees. I'm going to start with the degrees. See if you can go fast, guys. I'll say it out loud. 0 degrees. What's the next one? 30 degrees, then 45 degrees, then 60, and then right on the horizontal axis, right on the vertical axis, it's 90, then it's 120, then 135 degrees, then 150, then 180, 210, countdown city or whatever, 225, no, not 230, 240, and then 270, and then after that it's 300, and then 315, and then 330, and then finally you did one revolution, which is 360. All right, let's do the radians. You got to know at least the first quadrant. 0 radians, pi over, not pi over 2. I'm doing the 30-degree one. Pi over, not pi over 3 either. Pi over 6. Then pi over 4. And then pi over 3. And then at 9 degrees, it's pi over 2. So you got to know those. And then the rest is just, remember, the rest is just the property that we saw last time, right? The reference angle from here to here, that's pi over 3. So then that means this guy is 2 pi over 3. Because 2 pi over 3 plus pi over 3 gives you pi. So one integer less. Keep the denominator at 4. What's the integer in the bottom, in the top? So 3 pi. Keep the denominator of 6. So what's the integer on the top? So 5 pi. So there it is. There's quadrant 2. 2 pi over 3, 3 pi over 4, 5 pi over 6. At 180, it's pi. Keep the denominator of 6. In the third quadrant, it's 1 more. What's 1 more of 6? So put a 7 pi. Make sure to put the pi in there, guys. And then a 4. Keep the 4. What's 1 more of 4? So 5 pi. And then keep the denominator of 3. What's 1 more of 3? 4. So then say the pi, of course. 4 pi over 3. And then at 270, you just got to know that one. That's 3 pi over 2, which is pi over 2 plus pi over 2 plus pi over 2, 3 pi over 2. And then again, you keep the denominator of 3, double it, and subtract 1. So what's the top? 5 pi. And then put the denominator of 4, double it, subtract 1. What is that? 7 pi. This one has a denominator of 6, double it, and subtract 1. What is that? 11 pi. And then finally, a whole revolution, 2 pi. All right. Now remember, my radius is 1. So I'm going to fill those in really fast. So the perfect coordinates. So 1, 0, 0, 1, negative 1, 0. So here it is. 1, 0, 0, negative 1 at 90 degrees. Why did I put negative? 0, 1. 0, 1. And at 180 degrees, it's negative 1, 0. At 270, it's 0, negative 1. And when you go back at 360, that's also 1, 0. Oh, it's 0 back at 1, 0. Are we okay? All right. The 30 degree one, that comes from the 30, 60, 90 triangle. Do you remember what the x coordinate is? Maybe you remember the y coordinate. Yeah, square root of 3 over 2. It's the short leg times square root of 3. 1/2 times square root of 3, square root of 3 over 2. So square root of 3 over 2, let me write it a little better. Square root of 3 over 2. And the y coordinate is 1/2. At 45 degrees, both the x and the y are the same. It's square root of 2 over 2, square root of 2 over 2. At 60 degrees, the coordinates toggle. The ones that are 30, they toggle. So it's the same because it's a 30, 60, 90 triangle. 1/2, square root of 3 over 2. There you go. You got to know quadrant 1, guys. Quadrant 2 is the same. It's just that the x coordinates are negative. So just reflect them. Just reflect them. So at 120 degrees, the x is negative. So negative 1/2, square root of 3 over 2. At 135 degrees, or 3 pi over 4, the negative square root of 2 over 2. And then square root of 2 over 2 is the y coordinate. And then at 5 pi over 6, or 150 degrees, the x is negative square root of 3 over 2 and 1/2. Yay or nay? All right, yeah, stop me or slow me down, guys. In quadrant 3, just reflect it. Both of them are going to be negative. So negative square root of 3 over 2, negative 1/2. 5 pi over 4, or 225, they're both negative. So negative square root of 2 over 2, negative square root of 2 over 2. And at 4 pi over 3, negative 1/2, negative square root of 3 over 2. In quadrant 4, it's a y that is negative, guys. Yeah, I'm going to close the door because I find myself trying to hear what's outside. Not that I'm trying to. All right, now 300 degrees. 300 degrees, what is this coordinate? It's 1/2. Oh, yeah, the x coordinate is a 1/2. The x coordinate is a 1/2, guys. And then the y coordinate is negative square root of 3 over 2. At 315 degrees, they're both square root of 2 over 2, but the y value is negative. And at 330 degrees, or 11 pi over 6, that's square root of 3 over 2 and negative 1/2. And if you zoom out, it looks like this. It looks beautiful. Yes, miss? Quadrant 3. Yeah, the x and y are both negative because we're in quadrant 3. In quadrant 3, all the x and y coordinates are negative. Only the x is negative and the y is positive. All the y's are negative. How do we feel, guys? Yes, ask. Oh, go ahead. Sorry. Are we okay so far? All right. Check it out. This is the fun part. You guys ready? I'm going to go slow. I'm going to go real slow. So this says, how do we analyze something like sine of 150 degrees? So remember what we said on the second page. We said that sine was the y coordinate, right? So go to 150 degrees on your unit circle. And what is the y coordinate at 150 degrees? Positive 1/2. So I'm going to write sine of 150 is a positive 1/2. Do you see how we did it? Now, I know that you have a calculator that can do that also. Don't worry, I'm going to bring it back up. But guys, you're not going to have your calculator with you. As a matter of fact, when you take your AP exam, 60% of the exam is without a calculator, guys. So, check this out. I know that you can just, well, right now it says radian. So let me change the mode to degree. So if I put the mode in degree mode, look at this. I push sine 150. It better give me a half, or else I'm teaching you guys wrong stuff. And check it out. Does it say 0.5? Yeah, the calculator knows. Sine of 150 is a half. We just got it through looking at a unit circle. We went to 150, and we got the y value. So now let's see. Let's continue. Let's see if we can do a whole bunch. Sine of 60 degrees. Go to 60 degrees. What is the y value? That's square root of 3 over 2. Go to 315 degrees. Tan of 315. Tan is y divided by x. What's the y value? Divided by? If you type that, I'll put okay. Is there a better answer? Yeah, what's a better answer? Uh-oh. Okay, that's a better answer. Negative square root of 2 over square root of 2. Is there a better answer? Negative 1. Notice that this magnitude, focus, focus. Notice this magnitude and this magnitude are the same. One's just negative. Negative divided by positive is a negative. Are we okay? All right, let's keep going. Cosine of 330. Go to 330 degrees. Cosine is what? The x or the y? The x. What is the x coordinate at 330 degrees? It's positive square root of 3 over 2. Go to 180 degrees. Sine is the y value. What's your y value at 180? 0. Go to 90 degrees. Cosine of 90. What's your x value at 90? 0. Now this one says negative 30. So count clockwise. That negative 30 is like 330 degrees. Do you guys remember that? So it's going to be, was it cosine or sine? I already forgot. Sine. So negative 1/2. And sure enough, if you take your calculator and you go sine of negative 30, look at this, sine of negative 30, and I push enter, it gives me my negative 1/2. See? You're not going to have a calculator, guys, for the quiz. I'll talk to you about that in a little bit. Don't worry. So sine of 270. What's sine of 270? Go to 270 degrees. What's the y value? Negative 1. Sine of 120. Chav, I don't know where negative 120 is at. Sine of negative 120. I scroll down. Negative 120 would be where 240 degrees is at. That's negative 120. So what is, does it say the y value? Sine? Yeah, what's the y value? Negative square root of 3 over 2. Tan of 120. So tan is y divided by x. So negative square root of 3 over 2 divided by negative half. Oh, I said positive 120. I was still negative 120. Sorry, guys. Tan of 120, the y value is positive square root of 3 over 2, and the x value is negative half. Positive divided by negative is a, so negative square root of 3. Do you see how we did it, guys? I'll slow down. Do we see how we did it or no? No? Okay. Yes. You go to 120 degrees. So here's 120 degrees. And remember that we said that tan was y divided by x. So what was the y value? Square root of 3 over 2 divided by, what's the x value? Negative 1/2. Then the 2's just cancel out. Positive divided by negative is a negative, so negative square root of 3. Do you see how we did it, guys? Now ask, because I can't read mice. Oops, I accidentally deleted those. All right, let's see. What else do we got? Okay, don't freak out. These are just radians. It's the same. All right, guys, focus. So pi over 3 is like 60 degrees. So go to pi over 3. What is sine of pi over 3? Square root of 3 over 2. Tan of 7 pi over 4. 7 pi over 4 is in quadrant 4. That's a negative 1. Cool or not cool? Cosine of 11 pi over 6. That's in quadrant 4. Square root of 3 over 2. Sine of pi. 0. Cosine of pi over 2. 0. Sine of negative pi over 6. So that's like negative 30 degrees. Negative 1/2. A y value. Sine of 3 pi over 2. And I make mistakes. Let me know if I make a mistake. 3 pi over 2. Yes, sorry, I was drinking water. Negative 1. Sine of negative 2 pi over 3. Chubb, I don't know where that one's at. 2 pi over 3 is where 4 pi over 3 is at, but negative. Negative 2 pi over 3. So that's negative 2 pi over 3. So negative 2 pi over 3. Let me erase this before people get confused. So what's the y value? Negative square root of 3 over 2? Cosine of 2 pi over 3. That's in quadrant 2. What's that? Negative 1/2? Okay. All right, you're going to have a quiz on Friday. Relax. You probably already heard of it. We will drop the first 4 quizzes unless you get 100 right off the bat. They're called unit circle quizzes. Not to be confused with the UH unit circle trig quiz. The UH, we're just going to call the UH to not confuse it from the quizzes in class. Because the UH, the University of Houston calls those quizzes, but we're just going to call it UH. All right, here's how it works. It's going to look like this. And in the beginning, we're going to give you guys 15 minutes. We'll give you a blank unit circle. I'm not grading the unit circle, so you don't have to fill out any of it. And then you're just doing this. And before you start saying, child, this is impossible, blah, 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 I can't memorize all that. By the time you guys take, like, first of all, there's no pressure. Remember, I'm dropping the first 4. So I would say 99% of the time, by the time you take the 5th one, 99% of you will be at an 85 or higher with the unit circle quiz. Because by that time, you already have a lot of experience. Every day when we see each other, we're going to take the first 10, 15 minutes and do this. Relax. It's going to be simple. So I know what you're thinking, you're like, man, how am I going to do that really fast? All right, look. I'm just gonna write a whole bunch of random ones, and I want you guys to see that it's really simple. Like, Chav, you expect me to memorize all this? You don't have to memorize anything, guys. You just gotta store memory like the right way in your brain. That's really all it is. All right, look at this. No, really, look. This is a life skill. This is super important. You guys, in my opinion, can you guys memorize stuff like no one's business? Yes. But as soon as you are done with the quiz, as soon as you are done with the exam, you just dump all that stuff that you memorized. And then they ask you a year from now, I don't know. But my calculus students, I still ask them cosine pi over 3. Ask any of the calculus kids, what's cosine pi over 3? They'll tell you. They'll tell you real quick. And that's a year later. There's not any gimmick to it. You just got to make sure you place it in the right memory. Let me show you how to place it in your memory the right way, so you're not memorizing every single element of every single thing all the time. You gotta know quadrant 1. No quadrant 1. Pi over 6, pi over 4, pi over 3. Cosine of pi over 3, that's the same thing as saying cosine of 60 degrees. Yes or no? Cosine of pi over 3, what is the x value at 60 degrees, or at pi over 3? 1/2. All of them, if you see a 3 on the bottom, because these are special angles, all of them are a half. Either positive or it's negative. That's all it is. So cosine pi over 3, put equals 1/2. Put equals 1/2. So, I don't know if you're writing it. All right. Cosine 2 pi over 3. This is in quadrant 2. In quadrant 2, the x coordinate is negative. And you guys have known that since you guys were in 7th grade. Yes or no? So you already know you're in quadrant 2. The denominator is already a 3, so you already know that's going to be a half. So this has to be a negative 1/2. Do you see how we did it? You see how we did it, guys? All right. Look at this one. Cosine of 4 pi over 3. 4 pi over 3 is in what quadrant? In 3. In quadrant 3, everything is negative. So negative 1/2. Cosine of 5 pi over 3. Oh, well, 5 pi over 3, it's over 3, so that's a half for sure. 5 pi over 3, double the denominator, subtract 1. Oh, I'm pi over 3 away from 2 pi. I'm in quadrant 4. That's quadrant 4. And in quadrant 4, the x-coordinate is positive. So this has to be a half. Do you guys see how to do it? You don't have to memorize a whole bunch of stuff. All you got, if you're adamant, like, but you're still making this memorize. Okay, you're right. Memorize quadrant 1. But you don't even then, like, it's not a lot of brain power. Just memorize quadrant 1. If you know quadrant 1, you know them all. Does that make sense? So now I can just randomly say, what's sine of pi over 6? I'm like, oh, well, pi over 6, that's 30 degrees. Sine is a y value. Sine of pi over 6 is a half. If they tell you sine of 5 pi over 6, well, 5 pi over 6 is in quadrant 2, and it's still the y value. In quadrant 2, the y value is positive. Oh, that's a positive a half. If they tell you sine of 7 pi over 6, oh, chop, 7 pi over 6, everything's negative in quadrant 3. That's a negative 1/2. Sine of 11 pi over 6, oh, that's quadrant 4. It's still talking about the y value. So the y value in quadrant 4 is negative. That's a negative 1/2. You see how the memory works, guys? So does it take work? A little bit. It doesn't take a lot of work. I'm not telling you to sit down with your paper for 1 hour. It does not take 1 hour. It takes maybe 3, 4, 5 minutes. So during advisory, you just need 5 minutes. You just look at the paper, look at the unit circle, look at some patterns. Oh, okay, I got it. And then just practice. The more you practice, the better you get. You won't need 5 minutes next time. Next time you just need 1 minute. Just to look over it. Oh, 1 minute, got it. And then once you do it over and over, by the time you're like 2, 3 weeks into it, you just need 10, 20 seconds. Well, I just need to look at the unit circle real quick. Oh, okay, that's pi over 6. Okay, that's all I do. Cool. And you got it. Does that make sense, guys? Okay. So right now, all we're going to do is practice. So start with the delta math. You got 3 activities total. One of them is due today, because there's 2 of them on delta math. If you're fast enough, you can finish both of them. There are some people in first period that were fast enough and they finished both. If you're fast enough, you can finish both. One's radians, one's degrees. And then whenever you're done, see if you can tackle UH. The UH is not due until next Friday, but attempt it before Friday. Next week. All right, that's it.
Is it the UA?